Picture an old prospector kneeling by a creek, gently swirling a metal pan filled with river mud. They are relying on a simple physical fact: gold is incredibly dense. As they swirl the water, that heavy gold naturally... Panning by hand works if you are one person hoping to get lucky. But to run a real mining operation, you have to process massive mountains of dirt quickly. Early miners tried scaling up by building long, tilted wooden troughs. They shoveled raw dirt in, ran water down the slope, letting heavy flakes settle. Whether you use a tiny metal pan or a 50-foot wooden trough, the core strategy remains completely identical. We are simply letting gravity do the heavy lifting of sorting the gold. Modern engineers took that swirling, shaking motion of the pan and built massive machines to replicate it on an industrial scale. The first primary tool in the gravity separation toolkit is the jigging machine, a heavy-duty workhorse designed to handle enormous volumes of raw dirt right out of the ground. Inside a jigging machine, water pulses rapidly beneath a horizontal metal screen. Heavy gold fights the upward pressure, punching down through the screen to collect safely. Lighter waste dirt cannot fight the pressure and is swept out the top. Jigging gives you a high-volume, low-cost way to quickly capture the largest, heaviest nuggets directly out of the earth. But dirt holds much smaller, sand-sized grains of gold too. To catch those, operations use a second piece of equipment called the shaking table. Looking closely at this machine, you can see its slightly tilted, distinctly grooved surface. An overhead schematic illustrates the opposing forces. Water flows downward across the tilt, while the table violently vibrates horizontally. Mixed ore spreads out. Heavy gold grips the table, shimmying across the grooves, while lighter waste dirt washes straight down off the bottom. Both jigs and shaking tables achieve the exact same goal. They use precise physical motion and zero chemicals to isolate the heaviest, most visible gold. This physical process is cheap, clean, and incredibly successful at capturing coarse pieces of gold. But there is a major flaw built into the system. Physical gravity separation is practically useless at catching microscopic fine gold dust. Because the fine gold is just too small and light to sink, the rushing water sweeps it away alongside the dirt. Historically, miners solved this massive loss by soaking the leftover dust in cyanide to chemically dissolve the invisible gold, a process fraught with serious environmental hazards. Today's operations face a harsh reality. They have to extract that invisible dust to stay economically viable, but they must do it without destroying the surrounding ecosystem. The answer is a modern chemical solution designed strictly for the microscopic dust that gravity missed. We can think of it as a gentle soak. At scale, operations funnel massive quantities of that fine leftover ore into large vats like these. Instead of using toxic cyanide, responsible sites now pour in a safe, highly efficient alternative called Jinchan metallic ore dressing agent. Jinchan acts as a gentle soak. It efficiently dissolves and rescues the microscopic gold dust, doing the heavy chemical lifting while allowing the mine to achieve total environmental compliance. This flowchart illustrates the ultimate modern workflow. You start with raw ore, run it through gravity separation to catch the coarse chunks, use flotation for the middle-sized grains, and finish with Jinchan leaching to secure the invisible dust. Maximum recovery is about striking a balance. You combine the heavy physics of the big shake with the green science of the gentle soak.